Hi, this is Justin Shu, and I did the testing on the Tiny Tapeout 6, project number 423, the cyclic redundancy check. So how does a CRC work? A CRC is a error detecting code which is used to check if bits are changed in a package. How it does that is when sending a message, the message is sent through a CRC algorithm, which then generates a checksum through the algorithm. That that checksum is then appended onto the back of the message. And on the receiver end, when they receive the message, they generate another checksum, and they'll check the two checksums as well as the two messages, or they'll check the checksum with the message. So now, if anything changed, the receiver will know this message does not match this checksum. The Dallas Maxim CRC is the CRC that was used in this project. It has a polynomial of x to the 8th plus x to the 5th plus x to the 4th plus 1. 1 is the same thing as x to 0. And this is what it looks like with the each stage is a flip-flop, and the placement of the XORs determines the polynomial. The Tiny Tapeout chip itself takes single bit inputs, or how it interacts with the interface is it takes single bit inputs and it has a clock. So a new checksum is generated after each clock. So the final checksum will be the checksum after all the data has been submitted and clocked in. So there were three methods to testing this. The first is the walkway design, which allowed us to manually input data into the chip by, well, through pressing the clock and switching the input bit by hand. The outputs were able to be matched. We found that these LEDs in the LEDs on the Tiny Tapeout chip matched what happened to the LEDs in the walkway design. The second, or the other method we tested was the Arduino input, which sent 128 bits of data into the CRC and clocked them. And then a segment of the code written on the Arduino was actually also to check if the output was the same. So if you see in the left image down here, it says clock 253, input data 1, and then board 11101101, and the CRC matches. What happens is the data will stop flowing through if they find that it's wrong. So the Arduino code will be set to stop. The final method of testing was to just change a single bit, because if you change a bit, a new checksum will be generated. So this simulates an error in the data. So what we wanted to test was, if we change a single bit in the input data, will the CRC change? Will the checksum appended to the data change? We did find that it did change, so that was all correct. And in the next slide, you'll actually see videos of how it works. In this slide, it shows how the wires were connected. So because we have the Arduino code and we need to show how the clock was connected, how the reset was connected, and everything. So how the code actually works is it generates 8 random longs, which is the equivalent of a long. It has, I think, 16 bits, so 8 times 16, and that's, or yeah. So we use the data type, some integer data type, and we generated a random number, and then it cycles, and then it inputs those numbers through, well, division and modulo operations as bits. So it converts that into bits, and then it cycles it, through the CRC. And then the array was duplicated, and then it generates, and then a single bit was changed. The new array is then run through the CRC and tested to see if the outputs match again. And so at the end of the code, you'll see that the checksum is actually both checked on the serial terminal to make sure that they're different. So here's the first video. And in this video, we have the code, and it's mostly just the serial monitor output. At the beginning, it'll tell you which index was flipped. So out of the array of 8 longs, which long was chosen and which bit was flipped in that long. So, and then you see it cycle through all 255 clocks. So what happens is halfway through it, it'll stop and it'll tell you the input data, and then it'll give you a chance to maybe read the CRC. But that data is also still stored to the end, so you'll be able to still see that at the end of the program. So then at the end of the program, it tells you the data input, which it reads from right to left, so I added a little note there. And then the CRC output in hex. So if you see that the CRCs are different, that's a good thing, because we flipped one bit in the two sequences that we ran through. And then if one of the outputs for the CRC is -2, it actually means that either the CRC isn't connected properly from the Tiny Tapeout, or there's some sort of hardware issue. And if the output is -1, it means that the output of the code didn't run properly for some reason. And here we have a video of the code actually running on the CRC, between the CRC and Arduino. So as you can see in the little LED on there is changing. And right there it stops, it reset, and then it's running the other sequence. and that's just that's just to show you that this is the same code we're running. Yeah, and that's it.